In this video, we will discuss aggregation and grouping. Many often we would like to group data in our data frame based on a simple criteria, and then we would like to do some operations on these groups. The very common scenario is a scenario of the summarization and aggregation. For instance, maybe we would like to compute the sum, mean, median, minimum, and maximum. Well, of course we can do these operations on a data frame. But what if we want to compute the sum, for instance, per state, or the mean per type, or the median by something else? That's a group by operation in which we apply the aggregation over the groups that results from the grouping. Let's take a look here. We're going to use the display function here. Once again, this function has nothing to do with the topic of grouping and aggregation. It's just a helper function so that we can see a couple of data frames stacked side by side for presentation purposes. Next, we're going to load the planets dataset. This is an astronomical dataset. It basically lists a bunch of discovered planets since 1960s, I believe, and those planets since 1989 have been discovered using multiple methods. In addition, we have information about the orbital period, the mass, the distance from Earth to these planets. If you take a look here, I use the function called describe. The function describe is a very useful function. It basically runs all of the basic aggregate functions, including the count, the mean, the standard deviation, the minimum, the quartiles here, and the maximum over all of the quantitative variables in the data frame. These summary statistics are useful to get a basic understanding of what the dataset is about. For instance, taking a look at the mean, we can see that we have 1,035 observations in number, but 1992 in orbital period, 513 in mass, and so on. Why is it the case? Well, this is because we have some null values, meaning although we have in total 1035 rows in the data frame, they're not all populated when it comes to orbital period, mass, and distance. It means that we may discover a planet but do not know all of these variables about the planet. The describe function is an example of an aggregation function. And you can see here it operates on all of the columns of the data frame. This is something we have seen before. We have seen that, for instance, if we call the function such as mean, this function will calculate the mean column-wise. Planets.mean. Probably need to read the data here. Okay. It's going to calculate the mean over each one of these columns. Here are some of the aggregation functions that pandas provide. Count, first, last, mean and median, minimum, max, standard deviation and variance, mean absolute deviation, the product of all items, and the sum of all items. And those apply on a series as well as on a data frame. The difference is that if you apply it on a series, you get a single value. If you apply it on a data frame, you get a series of value because it's been applied on each column in the data frame. For instance, if I take planets here and put planet mass dot mean, I'm going to get one value, which is equal to this value here. But if I do planets dot mean, I'm going to get a series because the mean will be applied on each column of the data frame. Similarly here in describe, I got a data frame because each one of the functions, mean and count, has been applied to each one of the columns in the data frame. Now, so far all of these aggregations do not differentiate across rows in the data frame. They're basically the aggregate of all of the observations in the data frame. Many often we want to group by. We want to create an aggregation based on some criteria. This is called a group by operation, and it's very similar conceptually to the group by operation in SQL that many of you have seen before. Conceptually, the group by operation does three things. It takes the data frame and split it to groups based on a group by criteria. Next, it takes an aggregation function and apply it on each one of these groups. Say for instance I want to calculate the sum per key. First step is to split two groups, for instance group A, group B, group C. Second step is to apply the function sum on the data in each group, so we get 1 plus 4, 5, 2 plus 5, 7, 3 plus 6, 9. And the third step is to basically combine these results together to get the final result. So all of this will be performed under the hood, but also pandas provide different ways to access these intermediate steps, and it allows us to do some more powerful grouping operations than the ones that are typically done. Let's take a look at some of these examples here. I'm going to create a mini data frame here just for illustration purposes. That's what we've seen above, the key and the data here. To create the groups, I can use the function groupBy and pass in the group criteria. The group criteria can be a column name, so I can say okay, group by key, and I got a grouping object. So the grouping object is basically the intermediate object that results containing information about the groups. Basically, it's the object that contains all of these groups here. And we can access the group object if we wish to, for instance, and that's not something we typically do, but I can go over each group in the grouping and print the group, and I can see there is a group A, which contains the mini data frame here, a group B, which contains the mini data frame here, a group C, which contains the mini data frame here. I can also get a specific group. I can say grouping.get group A, and I get that mini data frame here. So that may be useful, for instance, if you want to get information about, you know, a sub data frame in which the value of key is A, you can do that. It's kind of like masking, but you can do a group by A, group by key, and then get group A if that's what we need to do. Many often we do grouping because we want to do aggregation. Once we do the group by, we can apply the aggregate function. So if I do group by A dot sum, group by key dot sum, I'm going to get this as a result. And here the sum function has been applied to each one of these groups, and the results were combined together, and I get here the final result here. Let's take a look at some options that the group by object has. If we group by, you get in a data frame, we get a data frame group by object. So if I do group by method, for instance, here I get a data frame group by object, meaning if I take a look at this group by object, let's take a look and do an aggregation. Let's do mean. You can see that we group by the method, but this group by object contains information about all of the other columns, including number, orbital period, mass, distance, and year. It's possible to index that group by object. It's possible to say, okay, planets group by method, I don't want the whole columns, I only want orbital period. And what we get here is a series group by object. So if I have a series group by object and then I aggregate, I get a series here because it's only looking at orbital period. It's not looking at all of the other columns here. Now let's go back to this one here. I'm going to pick median because it's to make it comparable. If I do median here, you can see that I calculated the median over all of the columns, and say I am interested in orbital period, I can simply take the orbital period here, and that will give me the same series as this one here, exactly the same numbers. So what's the difference in between doing this one, median, and then pick the column, and this one, do the grouping, pick the column, and then do the median. The difference is that this one is doing the median operation across all the columns, but then we're picking one of the results. This one is picking the column before doing the median. So obviously this one is much more computationally intensive because it's doing the median over 6 columns. This one is doing the median over 1 column. So if we're only interested in orbital period, then we're wasting some computational resources here. This one is not that wasteful because we are picking the column we want to do the median over. Now, practically speaking, for small data sets like this, we're not going even to notice that. But that becomes important when we have large data sets. To be more specific, if you want to aggregate over 1 column or 2 columns, we do that before running the aggregations. Let's take a look at the average time it takes to do this operation. This is the more wasteful operation, and this one is the less wasteful operation here. And we will notice that this one will take much more time than this one, probably 5 more times than this one. So 1.8 milliseconds average. And this one is 747 microseconds. So more than twice in terms of computational time to do that. That's something to keep in mind. You know, again, for small data sets, it's not a big difference. So we can access this group by the data frame group by object, and we can index it very similar like a data frame. If I want to do the median over 2 columns, say orbital period and mass, I can do fancy indexing here. And that will give me another data frame group by object that only contains these 2 columns. If I do the mean, for instance, I'm going to get that aggregate over these 2 columns. Now we can iterate over the groups. This is something we've seen above. The group by object contains information about the group, so it's possible to really take a look at what's under the hood if that's what we want to do. So I can do over each method group in planist.groupby, and I can print the key and the shape of the group. That's something we may want to do if we probably want to look at a specific group. We will see an example of that, but that's not usually the case. What we usually want to do is to dispatch methods, aggregation methods, to the group by object. For example, say I want to know the descriptive statistics per each by year. So by the methods, and I want to pick year as the column. So I want to know the first time this year this method has been used, and the last year this method has been used. The mean is not very useful, the median is probably okay, but that's basically running all of these descriptive statistics over the column year. So I do group by method, year, describe, and I get that. So I can see that astrometry has been used in 2010, and last time it has been used in 2013. Compared to other methods. Now obviously this is picking one column in the data frame, and this is the describe function, but basically we can do this over all different combination of columns or the methods themselves. So if I just want to do, for instance, the minimum, I'm gonna get a series here. It's basically the first time this method has been used. If I take out here, let's take out here, I'm going to get the minimum over all of the columns in my data frame, including year, but also distance, mass. So the minimum distance, the minimum mass, orbital period, and so on and so forth. So once we have the group by object, we can call the aggregate functions to get the result. And once again, many often we are going to use the built-in aggregate functions. in pandas, but there are also ways to create our own aggregate functions. Conceptually, there are three kinds of aggregate functions: aggregate, filter, transform. And it's also possible to create any function to do the aggregation. And this is by using apply, which is the most advanced way of dealing with a group by operation. So this section will be a bit kind of dense compared to the above, but that's kind of getting us to the more advanced uses of the grouping of group by in pandas. So here again, I'm going to create a data frame here, and this data frame has a key, and data 1 and data 2, those are the data columns in this data frame. Okay, let's take a look at some of these examples here. I wrote my aggregation function called myAgg, and this function as an aggregation function takes a series of values and it gives me a single value. That's conceptually the concept of aggregation. So what this function takes, it takes a list of values and it goes over each item, and it only looks at even items. So I for I in X if I modulo 2 is 0, and then it gives me back the length of this list. So basically it counts the number of even numbers in a list. So if I do 2, 2, 2, 3, 4, or 2, 3, 5, I'm gonna get 1 in this case, but if I do 2, 3, 5, 6, I'm going to get 2. So that's the function here, and this function takes a list. It can take a series. So for instance, if I do my agg of df data 1, I'm gonna get 3 because data 1 contains 1, 2, 3 even numbers. If I do df data 2, I'm going to get 1 because it only contains 1 even number, which is 0. Now, what if I want to use my function to aggregate different groups within the series? So for instance, how many even numbers are there in data when grouped by key? Well, in key A, there is one even number, which is 0. In key B, there is one even number, which is 4. And in key C, there is one even number, which is 2. Well, data 2, in key A, there is none. There is a 0 even number. In key B, there is one even number, which is 0. And in key C, there is no even numbers. And that's what we get here. If I do group by key, and instead of using one of the built-in aggregation functions, I use the function aggregate and pass in my aggregation function. I'm going to use this aggregation function over all of the groups in the group by object. And the group by object here is a group by data frame, so we're going to use this aggregation function over each column, data 1 and data 2. Another use of the aggregate function is to basically pass in a list of functions that we want to use to create the aggregation. So we have seen the use of describe, and describe will run all of the common aggregation functions. But what if I'm interested in only 3 of them, say minimum, the median, and the maximum? This is something we can do with aggregate. We can call aggregate and pass in the functions that we want to use to aggregate. For instance, I'm grouping by key here, and I want to aggregate using minimum, np.median, and maximum. And here it's saying basically you can pass in the function name in a string, or you can pass in the function itself. And this function can be a function from a package, or a built-in function in Python, or a function that you write yourself, such as my agg here. Doesn't really make a difference. And what you get here, you get the group by operation, and you get each one of these aggregate functions applied on the group by data frame in this case, because we have 2 things, data 1 and data 2. This is very useful if you want to be more specific about what you want to aggregate here. You can also specify which aggregate function to run on each column. So you can say, okay, on data 1 I want to apply min, on data 2 I want to apply max. So you pass in a dictionary mapping the columns to the functions, and you get as a result a more specific aggregation here, the minimum of data 1 and the maximum of data 2. You can also mix and match. You can say, okay, data 1 I want the minimum and the maximum, but data 2 I only want the minimum, and you get the minimum and maximum of data 1 but only the maximum of data 2. This is very useful if you want to do a very specific aggregation without running all of the numbers and selecting them after the fact. So that's the aggregation operator. Simply speaking, the aggregation operator allows you to select the aggregation functions to apply on your group by object, the group by data frame or the group by series object. And that can be a function that you write, that can be a built-in function, that can be a list of built-in functions, that can be a mapping between the columns and the functions that we would like to use. The second conceptual operation is transformation. Transformation is different from aggregation because it doesn't really aggregate the data. It basically transforms it, but this transformation itself relies on some aggregate property of the group. Okay, what does that mean? Let's take a look at the data frame here again. Here is my data frame. Let's say I want to subtract, for instance, some value from data 1 and some value from data 2. Well, I can do something like this. I can do, let's say the value here is 1, for instance. I want to subtract 1 from each value. I can do something like this, but I need to select data 1 and data 2. This one will not work because key is not a numerical value. So I'm going to select data 1, data 2, minus 1. And this will subtract 1 from each value from data 1 and data 2. Again, pandas will broadcast this operation. So we've got this adjusted value here. Well, so far so good. Now, what if I want to subtract a value related to data 1 and data 2? For instance, I want to subtract the mean from the average from data 1, the average value of data 1 from each value in data 1, and the average value of data 2 from each value in data 2. I can do something like this. I can do df.mean. That basically will tell me, well, look, df mean is 2.5 and 4.5. So I can do the same operation. I can do df.mean here. Now, the only thing we need to do is to tell pandas, well, let's do it in another column here, in another cell, excuse me. We need to tell pandas to do this operation on the columns, to align based on the columns, because otherwise it's going to align it on the rows here. So, for instance, minus, well, let's do df here. Okay. I want to see all of them. Okay, so 0 minus 2.5 is minus 2.5. 5 minus 4.5 is 0.5. And I can barely see here. 1 minus 2.5 is minus 1.5, and 0 minus 4.5 is minus 4.5. Okay, so that basically called demeaning. We are removing the mean of each one of the variables from each value of that variable column. Now let's take it one step further. Let's say we want to do this demeaning operation based on the groups, meaning I want to take the average of I don't want to subtract 2.5 from data 1. I want to subtract 1.5 because the average of data 1 per key is 0 plus 3 over 2, which is 1.5. Let's take a look here. I'm going to do df.group by key dot mean. This basically says that the average value is 1.5 for data 1 when the key is A, and the average value for data 1 is 2.5 when the key is B, and the average value of data 1 is 3.5 when the key is C. So then the transformation I want to do is to basically subtract 1.5 from let's see the data frame again, from 0 and subtract 2.5 from 1 and subtract 3.5 from 2. Now this operation is very common. It may seem weird in the beginning, but this is basically a demeaning operation over groups. For instance, if you want to take out a trend, for instance, from a certain series of values, and those values are grouped, maybe those are, for instance, information about salaries in certain companies A, B, and C. It makes sense to take out the average so that you can compare individual salaries, whether they are above the average or less than the average in the specific company, for instance. So this is a very common operation, and we want to do the transformation over the group. And that's basically the transform operator. I want to group by key, and then instead of aggregate, transform. And when I transform, I write a function that takes here the certain lambda x, and lambda x will be the group here, and I want to subtract the mean of that group from each individual value in the group. That's x minus x dot mean. Okay, so again, this function will be applied on each one of these groups, and each one of these groups will be the group by the group in the group by object. I'm simply taking the group minus x dot mean. That's very similar to doing df data 1 data 2 minus df data 1 data 2 dot mean. But instead of this being applied on the whole data frame wholesale, this transformation operation will be applied on each one of these individual group, and each one of the individual group here is an x, so x minus x dot mean is going to be this operation, and that's the transformation here. Let's take a look more into what's going here under the hood. Instead of writing a lambda expression, I'm going to define my function. Let's call it my transformation, and this my transformation will take an x. So I'm going basically to return x minus x dot mean. So that's basically the same, exactly the same. Let's run this cell, my transformation. Same result, except that I'm going to print x here just to show you what's going on. And you can see here that for the first x, we're going the grouping. It doesn't print out very nicely here. We are basically doing data 1, 0, and 3 for A, right? So 0 and 3 is the first one, and 5 and 3 is the one for B. So that's the first group for A, and that's the second group. So the first group in data 1, the second group in data 1, the first group in data 2. So that's basically the first one, 0 and 3 and 5 and 3. That's the second one, 1 and 4 and 0 and 7. And this is this one, 2 and 5 and 3 and 9. So that just serves to see what's going under the hood when we do that transformation. And we can also write a function or a lambda expression. It doesn't really make a big difference here. It's a just simple transformation. Next, we'll talk about filtering. Filtering is basically, as the name implies, selecting observations. Again, it doesn't do grouping here. It basically selects from the rows on the data frame. But this selection inherently involves a group level criteria, a group level condition. So we need to write a filter function, and this filter function operates on the group itself. And this function needs to return a Boolean, true or false. And then when we do the filter operation, Panda is going to call this filter operation on the group, and is going basically to delete observations that don't satisfy the filter function. Okay, let's take a look at this example here. Here my filter function is the standard deviation of data 2 is greater than 4. So if we do group by key standard deviation, you can see that only keys B and C satisfy this criteria because the standard deviation is 4.9, 4.2. The rest of standard deviations are not here. Basically, that means that we want to exclude key A because key A doesn't satisfy this criteria. So when I do df group by key filter function, I'm going to see only observations pertaining to B and C because group A doesn't satisfy this filtering criteria. So again, this is filtering based on a group. If we want to filter based on observations, we need to do masking. There is no need to do this. This is only needed because we are filtering on the group. And you can see here that this filter function is dealing with the group by object here, which has data 1 and data 2. And thus my criteria is standard deviation is greater than 4. I can't do x standard deviation greater than 4 because this will give me a Boolean series. But I can select based on them. So let's say, for instance, either the standard deviation of data 2 is greater than 4, or the standard deviation of data 1 is less than 2. Well, no, that's not very meaningful. Well, let's do it anyhow. If it's less than 2, it means we're selecting A back again because it satisfies the criteria. So here we do standard deviation of x data 2 is greater than 4, or the standard deviation of data 1 is less than 2, and none of them satisfy it, so that's why we don't get A. But if I do less than 3, for instance, I'm gonna get A back again here. So that's not a very meaningful example. The point in here is that the X here refers to the group by object, and it's a group by data frame because I have data 1 and data 2. So can I access the group level characteristic of data 1 or data 2? Okay, finally we're going to look at the master function apply. Apply means it's up to you to come up with a function that will be applied on the groups, and those groups will put together back again. So all of those functions that we have seen, transform and filter and aggregate, they're applied on the groups, but then they have their own logic. Here there is no logic. Anything you want to do will be operated, and you'll get a mini group by object that will be put together in the resulting data frame. For instance, what I'm doing here in this function, I'm dividing data 1 over the sum of data 2. So when I do group by and apply norm by data 2, I'm getting something like this. Data 2 is kept intact because I'm not changing it, it's the same, but data 1 is been normalized by the sum of data 2. So for instance, data 1 here, it's 0 divided over 5 plus 3, which is 0. Data 1 here is 1 divided over 0 plus 7, 1 divided over 8. And that's the result. Data 1 here is 2 divided over 3 plus 9, 2 divided over 12, which is 1/6, and that's the result here. Okay, and this is up to me. I can do whatever I want. Let's say I want to multiply then data 2 by 2. I'm going to get twice data 2 here in the aggregation. So it's doing whatever we want to do. We can even return the mean of that. We can do the average of the resulting stuff, and it still will work. It will do the transformation and does the average. So again, I mean, this is writing your own function that operates on those mini data frames before they are put together by the key. Finally, let's talk about different ways of creating the groups. Specifying the split key. So far we've been specifying the split key to be one of the columns in the data frame. We have other options here. First, we can pass in kind of like a mask, a list or a sequence of values that indicate which one of the observations belong to which one of the groups. For instance, I can say that the first observation is in group 0, the second is in group 1, the third is in group 0, group 1, group 2, and group 0. So that basically specifies, here is an example, specifies a different way of the grouping compared to the key. It's kind of completely an external object that specifies the grouping. And you can see that group 2, it's only one observation, which is B here. So I've got 4 and 7 because that's the sum here. So I specify the grouping in a completely different way. So obviously passing the key is passing the column is one option. But we can also pass in the column as an external object. I can take out df key as a series and make it to create the grouping here. That may seem a bit redundant, but the value in here is that it means that you can use any series or any dictionary for this case to create the group itself. Let's take a look at this example here. Now, I created another data frame called df2. I just set the index to be key. Now, I created an external dictionary mapping each one of the values in the key to a group. So A is a vowel, B is a consonant, and C is a consonant. I can now do the grouping based on the mapping. And this mapping means I have two groups, a group called consonant and a group called vowel here, and that's what I'm getting here. Of course, the other alternative is to create another, well, I'm going to do it in a completely different way, but will be the same result. The other way is to create a third column in our data frame called type. And type will depend on key, so type will be df key dot apply lambda x mapping of x. And now you can see that I created a fourth column which has the type vowel or consonant here. The next step is to basically do group by type, and did we do the sum or count? Okay, and sum, and that will basically be the same, right? So what we have done above is that we kind of circumvented creating a fourth column in the data frame. That's possible, it's up to us. I mean, again, pandas is giving us options, and there are different ways to get to the same grouping result. Finally, it can be any Python function. We can create a function, and this function will be applied on the index, and the similar values will be grouped together. For instance, here I just made the index lowercase, and obviously here I have ABC. But for instance, if I do count the length of the index, all of them have length of 1, so I'll get one group here. Oops. It's not str.len, it's group by len. And you can see that now I took the grand mean because all of these keys in the index have a length of 1. It can be any function, that's just to say, that operates on the index itself. So that summarizes the grouping and aggregation in pandas. There was a lot of information in this lecture. The basic operations, grouping and aggregation, we will be using those 90% of the times. For the 10% instances, just being able to understand how the group operation is being conducted conceptually and be able to write more advanced functions will be useful and important for those 10% of situations where the built-in aggregations are not satisfactory. And this is where, a tool like Pandas shines compared to SQL, where you're limited to use one of the built-in aggregation functions all the time.